Okay, so I've started the recording. So yesterday we looked at, just briefly at the end of class, we talked about how the probability a continuous random variable x lies between a lower limit and an upper limit is the probability of the upper limit minus the probability of the lower limit. Come on. I don't have time for technical difficulties. Okay. So probability of the upper minus probability of the lower. So what we're going to do today, we're just going to jump into it and start applying this. That's it. Okay. So they want us to use our tables to find the probability that z is between negative 1.37 and positive 2.34. So based on our little formula, we have to say that we want the probability that z is less than 2.34 minus the probability that z is less than negative 1.37. Now, I didn't get to talk too much about it yesterday. The reasoning behind this is if we just said minus 2.34, we're including this white tail right here. Do we want that white tail that I just shaded in? No, we don't. When we subtract it out, boom, it goes away. So that's why we do big minus small on these. So using our table that dual credit I gave you yesterday, AP, it's in your formula chart. What is the probability that z is less than 2.34? 0.9904.
How do you find that in the table?
So in the table, you'll see like a column going down the side that says 0.0, 0.1, 0.2, and so on. You want to look for the first two digits. So in our case, you look for 2.3 going down the side.
Sorry, I was talking about like what? How do you find the number? Like which number do you know to use? Like between negative 1.37 and 2.34. Like how do you know to use 2.34 as the one to base the chart off of?
Because it gives it to us.
But it gives negative 1.37 too, doesn't it?
Yeah. So we have to find both of them.
Oh, okay.
We've got to find the probability of the bigger one, and then subtract out the probability of the smaller.
I thought that was the answer. You're supposed to subtract.
Yeah.
Thank you.
And then, what's the probability of the smaller one? Negative 1.37. 0.0853. I'm just going to put this out there, if I start trying to go too fast, stop me and start asking questions. Because when I feel like I get, and this is with anything, if I start feeling like I'm getting behind, whether it's teaching or working on something, I'll start just working really fast. and then start messing up and leaving stuff out. So I start doing that. Don't tell me slow down. Okay, so when I subtract here, what would I get? 0.9051. There's our probability. Questions on this one? Okay. Flip over to example 8. So 8, they give us two new values, but the same process. We want to find the probability that z is between 0.54 and 1.61. Which one do I put first? Which one goes first? The probability of 1.61 minus the probability of z being less than 0.54. So then I'll look at my chart. And what would it tell me for 1.61? That's right. Now do the same for 0.54.
Why is the probability that z is less than 4 greater?
So, what we're doing when we find these probabilities in the table, anytime you use the table will always give you less than. So we're having to find the whole big probability from this green all the way to this area too. That's what the table gives us when I find this first value. But I don't want all this white area.
Oh, okay.
So I've got to subtract out that piece.
All right, let's see.
Uh-huh. If I subtract those, what will I get? 2409. Questions on this one? Yes. Okay, next one. We need to find the probability that z is between negative 1.42 and negative 0.93. So which one goes first? Since it's a range, I'm going to have to subtract. So which one do I find first?
0.93.
Negative 0.93. That's right. The big one always comes first. Then the small one comes second. So on this one, what's the probability that z is less than negative 0.93? What's the probability that z is less than negative 0.93? What was that? One more time.
0.1762.
0.1762. That's right. That's okay. What's the probability that z is less than negative 1.42? That's right. So altogether, our probability would be what? 0.0984. Yeah. Questions on this one? Are we good with having to subtract them like this?
Yes, sir.
Yes.
We leave it 225 or like, so we have a short period.
Yeah, we did. That's why we had to get in and get started.
How much time do we got here?
Normal time, 225.
Okay. That's pretty short.
Okay. So the next one, we're going to actually change things up a little bit. Up until this point, we've been starting outside the table and working our way in to get a probability. Now we're going to go backwards. We're going to start inside and work our way out. Now, I'm actually going to skip right quick to skip down to example 12, and then we'll go back and catch 10 and 11 here in a second. So, because 12 has a table, I can actually illustrate what I'm wanting us to do, rather than saying, oh, this is how you do it, help you understand my air motions. Okay, so example 12. Suppose we're interested in finding the z value for the smallest 2%. So the smallest 2% means we want our probability. We want the probability equal to 0.02. And that's what we have down here. That's how they got this probability that z is less than. This is what we're solving for. I'm going to put solve in quotes because there's nothing really to solve. But that's what we're wanting to find. They give us the probability this time. But here's the way you do that. You'll look at, usually we start by looking on the outside. of the table, and then we work in. Now let's do the opposite. We want to look in the middle of the table and then go out. So which one of our values in our table is the closest to 0.02? 0.0202. That's our closest value. Now, if this were like an actual college class, like a junior level college class, I'd expect you to calculate it to probably 4 decimal places. But we're just looking for the closest number. We're not going to do what's called interpolating and all that stuff. We're just going to estimate. Okay, so that's our closest. Now we go out. Go out into the world. So what number would this make? Negative 2.05. So Z star is approximately equal to negative 2.05. Does that make sense how we start this time in the middle and go out? I think 13 comes with the table too, so we'll go and do example 13 next because it's got a table. So I can illustrate it one more time. Does it come with the table? Let's go back. Okay, let's set it up first, and then I think our table will pop up. Yep, there it is. No, go back. Come on. There we go. Okay, so suppose we're interested in finding the Z value for the largest 5%. So that means this shaded area, what decimal would this shaded area be? 0.05. But does our table give us the area to the right? No, it gives us the area to the left. So what's the area to the left of this big white area? 0.95. So ultimately, what we want to find is the probability that Z is less than Z star, which is what we're solving for, equals 0.95. Okay, so let me advance this. Okay, so I need to look for 0.95. Which one looks to be the closest? On 0.9505. Oh wait, these are the same distance, right? That's right. These are the same distance, so we split the difference up here. And we're going to use 0.045. So,
where do you get the 94, 95, and the 95? Like, how do you find the number again?
these are from our table. These values are actually given in our table.
Yeah, well, what makes you like select those numbers?
Because we want our probability to be We want our probability to be 0.95 because we're interested in the top 5%. But our table doesn't give us the top percent, it gives us what's less than that value. So how much, if the top is 5%, how much is below it? 95%. So we're looking for the probability of 0.95.
So you look just like a little between that table?
Look for the one that's closest to 0.95 in your table.
And you pick those two just because they were like equal apart from each other?
That's right. So we looked, and if we were like counting here, right here, we would run into eventually 0.9500. You get, like if we're just, think of it like we're just counting all the way through here. We would go through that value right here in the middle. Does that make sense?
Yes, sir. I understand that. Thank you.
You're welcome. So since 0.045 is exactly in the middle, 1.6 is what we start with. Z star is 1.645.
Is it always going to be called Z star?
Yes and no. I mean, for this class, yes. I didn't really call, when we were in college, I didn't use the term Z star. What they did in college to make it even more confusing for us, they used capital Z and lowercase z. That's not the notation this book uses. Any other questions on example 13? Okay, so now let's go back and catch example 10. Okay, so we want to find the point Z with 98% of the observations falling below it. We want the probability that Z is less than Z star to equal what? If I want 98% to be below. What do I want my probability to be here? 0.98. That's what I'll look for in my chart. I want to look for the closest value to 0.98 in the middle, or 0.98 in the middle of my chart. Don't start on the edge. Look in the middle of the chart. What value do you find that's the closest to it? What's that? Let's see. The closest, I don't have a chart up here, but if you looked in your chart, you would see two values, 0.9798 and, if I'm not mistaken, 9803. Which one's closer? 9798. That's the one we want to base our answer off of. what value is what value gives us that probability? 2.05. That's what it says down here. The corresponding z value of 2.05. Questions on this one?
0.9798, that's what you get from doing the inside out thing, right? Okay.
Well, that's not our answer. Our answer is 2.05. This was just like if I look in the table, I would see these two numbers in the middle of table. In the middle. Of the table. I would find those two numbers, and then I would have to pick which one's it closer to. Which one is 0.98 closer to? That one, right? So then from there, I would have to go out and up to get my value.
Okay.
I just don't have a table built into the slide to show it.
Some stuff belong between them. Oh, because they're not equal. I see.
Yeah. Okay, let's look at B. So B asks us to find the point Z with 90% of the observations being above it. Does our table give us the values above something? No, what does it do? Below. If 90% is above, what's below? 10%, good. So 90% is above it, 10% is below it. So I need to look for the probability of 0.1 in my table. So when I'm looking in my table, I get like a negative 1.2 on the outside. And then eventually I'll see something, and depending on if you have AP formula chart or the dual credit chart, or dual credit flipped the table for some reason, I'm not sure why. But you'll see two values that are on either side of 0.1. See 0.0985 and 0.1003. Which one of these is closer? .003, so based on that value, you'll go over to hit 1.2. And what do you go up to hit? 0.08. So that means our Z star is what? Negative 1.28. 1.28. Questions on this one? Okay, number No questions, then flip over to the next page. Okay, now we have been dealing with the standard normal curve. In real life applications, not everything follows the standard normal curve. Most things don't. So what we have to do is something called standardizing the variables. Standardizing the variables. To find the probabilities for other normal curves, you standardize the relevant values, then you use the table of z-scores, or z-areas. We have an extra step before we can just turn to our table. If x is a random variable whose behavior is described by a normal distribution with the mean mu and standard deviation sigma, then we have a few properties. When we standardize, let's say we have that variable x and we want to find the probability that it's less than b. That's the probability that z is less than b star. Now what is b star? B star is equal to our b minus our mean divided by the standard deviation. And let's say we have a probability that x is greater than a. That's the probability that z is greater than a star. A star, even though our sign is greater than, a star is found the same way. You take a, subtract the mean from it, and divide by the standard deviation. And then the probability that x is between a and b is the probability that z is between a star and b star. So where z is a variable whose distribution is the standard normal, and there's our formulas. We wrote them already, but that's what a star and b star are.
Both A star, like both A star from B star, or like afterwards, or
Yeah, so afterwards, the next step from this part right here would be to do probability of z is less than b star minus the probability that z is less than a star. That would have been your next step. So again, this is what's called standardizing your variables. So if x has a normal distribution with a mean of mu and a standard deviation sigma, then the standardized variable is z equals x minus mu over sigma. And then our variable has a normal distribution with a mean of 0 and standard deviation of 1. So again, this is called the standard normal distribution. Yeah, let's look at an example. The data on the length of time to complete registration for classes using an online registration system suggests that the distribution of variable x being time to register for students at a particular university can well be approximated by a normal distribution with a mean of 12 and a standard deviation sigma equals 2 minutes. What's the probability it will take a randomly selected student less than 9 minutes to complete registration? So remember, x is our time. So we are essentially being asked to find the probability that x is less than 9. Since we're told this is normally distributed, we can use the standard normal table, but first we have to standardize our 9. So to standardize the 9 and turn the x into a z, we'll do 9 minus 12. So our variable, or I should say our value, minus our mean, divided by the standard deviation. When you put this in your calculator, I'll caution you now because third period had an issue with this. You can't just type this in. Because then it just says 9 minus, and then does 12 divided by 2 to get 6, and says, oh, answer's 3. You don't want it to do that. You want it to do 9 minus 12 first, then divide by 2. So make sure you put parentheses in there. You type the whole thing in at once. What do you get for your z-score? What's the standardized value? Negative 1.5. Good. This is the probability that z is less than negative 1.5. Now we can look at our table and find negative 1.5 on the table to get our probability. So what do you get for your probability? .0668. Good. What's bad is this just goes to show how old this problem really is. In most colleges, it takes you probably about 30 seconds to register for classes. In college, it should take you about 30 seconds to register for classes. What's that?
You just say I'm taking this class.
Well, what the way most colleges do it, you have a course number. So you get to pick your own courses, or your own section, I should say. Like your advisor, you'll meet with they're not called counselors in college, they call them academic advisors. You'll meet with them and they're like, okay, to stay on your degree plan, you need to take these classes. And then you just go out and you pick whatever professor you want that teaches it and whatever time you want it, and stuff like that. But with that being said, since everyone gets to pick, when that window opens up, let's say your time is 9 o'clock, you better be logged in at 8:59, hitting refresh until it opens, and then type all your numbers in as fast as you can and hit enter. Because if you're not doing it, someone else is, and then they're going to take your spot and you won't get into class. So it's every time I registered, almost every time, not long after, I would get in right at first. Not long after, they'd send an email out saying, please bear with us, the system has crashed. Well, I got my classes. What's aggravating is when you do that, and then it comes back and says, I failed to register you for this class because the section is full. Somebody was quicker than me. Okay. Next one. What's the probability that it will take a randomly selected student more than 13 minutes to complete registration? We want the probability that x is greater than 13. Well, before I even think about, oh, the table gives me only less than and all that stuff, let's standardize. That should be your first step almost every time. Standardize. So let's standardize this. Turn our x into a z. And then we have to do our 13 minus the mean divided by the standard deviation. The probability that z is greater than,
It gives you the mu every time, right?
it'll give you the mean and standard deviation, yes. Formula that we're using is x minus mu over sigma.
That's right, we have
Yes, you may.
it's not that hard.
Yeah, I was gonna say it's not hard to memorize. Honestly, this is gonna be on test 3. By the time we get through most of the test 3 material, we'll have it memorized. We're gonna use it almost every day from this point forward. Okay, so what do we get for our standardized value? 0.5. So we want the probability that z is greater than 0.5. Now, does my chart give me that? It gives me greater than 0.5?
That's there.
Gives me less than 0.5, so that means I'll have to subtract that value from 1. So what is the probability that z is less than 0.5?
Which chart are we using again?
The standard normal.
Gotcha. Is it 0.72? All right on that or not?
No.
No. I'm gonna do it right.
Oh, 0.6.
0.6915.
Oh, yeah, it's from the other way. Oh, my bad. You have to do it from the inside out, right?
Well, this one we do it normal. The only way we do inside out is
So 0.5. Oh, I was on the, wait, no, hold on, I'm confused.
the 5.5 in the column,
Yeah, I found
and then go over to
it. 0.00.
0.00, which is right there.
Oh,
They flip your
using
table
this
on
one
you.
over here. Oh. I see, no, okay, I got you.
They flip your table.
I had to write out this long area.
Yes.
Huh? You know what you're talking about?
Yeah.
See?
Okay, so when we subtract, what do we get? 0.3 something. 0.3085. Yes. Mm-hmm. Okay, questions on this one? Okay, on to the next. What's the probability that it will take a randomly selected student between 7 and 15 minutes to complete registration? We want the probability that X is between 7 and 15. So you would work this the same way. We just need to standardize both variables first.
Was that the answer? 0.0?
Yes.
Oh, okay.
So I need to standardize my 7 and my 15. So I'm going to do 7 minus 12 over 2. C, which is less than 15 minus 12 over 2. Okay, so what do I get for my first value? Negative 2.5 less than Z, which is less than 1.5. So this is like what we started class doing. We have to subtract the probability of the big one minus the probability of the little one. So probability that Z less than 1.5 minus the probability that Z less than negative 2.5. So what's our probability that Z is less than 1.5? You said 332? Okay. Minus the probability that Z is less than negative 2.5. 0.0062. You said 62?
Yeah.
Okay, so if we subtract these, what do we get? 92. Should be 70. Questions on this one? Okay, next one. Because some students don't log off properly, the university would like to log off students automatically after some time has elapsed. It's decided to select this time so that only 1% of the students will be automatically logged off while still trying to register. What time should the automatic log off be set at? Well, notice this time they're giving us the probability. They give us 1% needs to be logged off. So probability that Z is greater than Z star is 0.01. But does our table give us greater than? No, it gives us less than. So what value should I use for my probability? I can't use 0.01. 0.99. Which means I have to figure out what Z star gives me a probability of 0.99. So this is where we look in our table and go outwards. We look in the middle and go out.
How do you establish that it's Z is greater than Z star? Like, how do you establish that? How you start to
So here they want the longest 1% to be logged out. So since they want the longest 1% to be logged out, that means Z needs to be greater than some value. Have you ever been on like a machine where after so long it just kicks you out? That's what they're doing here. They only want 1% to be kicked out before they're done. So since they only want that extreme amount, we want to be greater than. Does that make sense?
Yes, sir.
So if we look in our table, what would Z star be? 2.33, that's right. Z star is approximately 2.33.
What do you do there? Just look for 0.99 somewhere in here?
Yes. Okay, now that's not what they ask us. They don't ask us for the 2.33. They ask us for the time. So I have to set up an equation here to find my x. I have to do x minus my mean divided by the standard deviation. That's what has to be equal to my z star. Because it's asking for time. Time is our variable. So how can I get rid of that 2 on the bottom? Multiply. So that's going to give me x minus 12 equals 4.66. Add the 12 over. X equals 16.66 minutes. So after 16.66 minutes, they're going to kick them out. Questions on this?
You can keep it right there.
Yep. So our next examples will pretty much follow this concept.
16.66 as well, and,
So,
oh, you just kind of algebra it?
yep,
Okay.
I algebraed it. We haven't done much algebra this semester, so time we bring it back.
I'm not having to do it.
Okay, next one. Okay, these are just solutions. Okay, so they give us a hot sauce example. They say they sell 20-ounce jars of pecani sauce. The true amounts follow a normal distribution with a mean of 20.2 and a standard deviation of 0.125. So I'm going to write this. I'm going to write this right here. So they said the mean was 20.2. Standard deviation was 0.125. Okay, what proportion of the jars are underfilled? Well, if they're underfilled, that means they have less than what their advertised value is. They advertise 20 ounces. So if X is how many ounces are in the jar, we're looking for the probability that X is less than 20. But I can't use my table like this, so I've got to standardize. So 20 minus 20.2 divided by 0.125. So what do we get for what do I get for my standardized value?
Negative 1.6.
Negative 1.6. So since it's saying less than, we can go straight to our table to find that probability.
Right?
0.0548. Questions on this one? Okay, on to the next. What proportion of sauce jars contain between 20 and 20.3 ounces of sauce? So we need the probability that X is between 20 and 20.3. Which means first thing I've got to do is what? Standardize. So 20 minus 20.2 over 0.125 less than Z, which is less than 20.3 minus 20.2 over 0.125. Yeah, I'm right on top of the chart. That's I know I'm going kind of fast. My goal is to at least get this hot sauce example finished. What's my first standardized value?
0.0548.
Okay, so
Wait. Oh, wait, I was looking at the other thing. My bad. It was negative 1.6. I looked at the wrong number.
yeah, which means that's a good sign, because that means you're ahead of us. Okay, 1.6. What's our second value?
Right.
8. Okay, so when we subtract these, we do big minus small. So probability that Z is less than 0.8 minus the probability that Z is less than negative 1.6. So what's the larger of our Z-scores here? 0.8. What's that probability? 0.7881. And then the other probability, as Riley said earlier, was 0.0548. We subtract these values, and what do we get? Should be 7333. Okay, do y'all want me to try to run through that 99% one? No?
I mean, is it any different or is it just practice?
It's the one that we did for the find the one where they get kicked off on the minutes. Yes.
Is there any way? At a certain point, you just find like
Not be.
Well, we're never really gonna get to use the equation. It's, I can show it to you right quick. It's a horrendous equation. You don't want to.
I feel like
Yeah. Well, so remember for these probabilities,